Hi, welcome back to this channel. In this video, we are going to start with chapter 8, Reaction Kinetic. In this topic, we have three parts. First is reaction rate. Second, correlation theory and transition state theory. And the third is factors that will affecting the reaction rate. Generally, these are the learning objectives in the first part, rate of reaction. However, in this video, we only will focus on what is the definition for reaction rate, and then how to write the differential rate equation, and then using the differential rate equation to determine the rate of reaction. Let's recall what is the definition for reaction rate. Generally, we can say that it is change of concentration of product with the time or change of concentration with the time. So the unit of concentration can be in mole per liter or either in capital M with time, so it's per second, per minute, or even per year, per hour, also no problem. When you want to plot the graph concentration against the time, so here we know that it is referred to the rate of reaction. So basically the rate of reaction also represented by the gradient of the graph. So now let's show you the graph. So from here, the y-axis is the number of molecules, so which refer to concentration. And the x-axis is referred to the time. So from here, we notice that the concentration A is getting lower and lower with the time. So we know that A is the reactant, while the concentration of B is getting more and more. So B will refer as product. So if we find the concentration against the time, so it is referred to rate of reaction. So again, the rate of reaction basically is represented by the gradient of the graph. So if you notice that there is a negative sign here, so we are going to know that the A is the reactant. Okay. Well, for this one, it will be always better that you put the positive sign so that it will be very clear that the B is the product. Generally, there are two types of rate of reaction. First one is the average rate of reaction, at where generally is the rate of reaction over a period of time. So you can find out the change of the concentration of the reactant over the time. So the triangle sign here generally is referred to change. So second type of rate of reaction is instantaneous rate. So basically from the word instant, that's mean we know it's at the time. Okay, which is like here at a specific time. So for this one, you need to draw a tangent line, and then next you find the gradient of the tangent line. So it will refer to the instantaneous rate. Now let's refer to the graph here. And then we try to learn which line is represent average rate of reaction, or which line is represent the instantaneous rate of reaction. Based on the diagram here, we can know that the H2O2 is the reactant. Why we say that? Because all these three lines, red, blue, and also the black color or the purple one, the concentration is getting lower and lower. So like just now we mentioned, if the concentration is getting lower and lower, so the substance will refer as reactant. Next, the average rate of reaction will be determined from the purple line. Okay, so this is the purple line. Okay. So, and then if we want to determine the instantaneous rate of reaction at 300 seconds, so we're going to determine by the red line. So you will notice that a tangent line at 300 seconds is drawn. Okay, so this red line basically is a tangent line. While the initial rate of reaction, initial means permulaan in bahasa. So that means we are draw a tangent line again, which is from the starting here, so which represent by the blue line. Sorry. After knowing the definition of rate of reaction, and then also based on the graph, how you can able to determine the reactant and the product, then the different type of rate of reaction. Then now in this subtopic, we are going to continue with the differential rate equation. So first we need to have an equation. When we have this equation, we will going to read this equation like this. Every 1 mole of nitrogen and will react with 3 mole of hydrogen, and then will produce 2 mole of ammonia. However, now we are doing the differentiate, means mathematically. So we are going to show like this. Rate of reaction will equal to negative D concentration N2 over dt. Negative, which will show that nitrogen is reactant. Wow, this means is change of concentration over the time. So for the hydrogen, also the negative sign, then we know that hydrogen is the reactant. But here then we will over the 3 because of this, there are 3 more of hydrogen. While for the ammonia, you can see here we supposedly will put the positive sign and then refer that ammonia is the product. So when we write this equation, okay, so what's that this mean? Okay, the equation means that the rate of disappearance for the nitrogen is 1/3 the rate of disappearance of hydrogen and 1/2 of the rate of formation of ammonia. So in simple word to say, if it is negative sign refer to reactant, positive sign refer to the product. So this number over here basically is refer to the coefficient in balance chemical equation. Let's repeat again how we going to write the differential rate equation based on the chemical equation given. Okay, so this is a general reaction. So from here we know that A and B are the reactant. So that's why you can see that there is negative sign in front of A and B, while C and D are the product. So you will notice that there is no sign, or it will be better you always add on the positive. Okay, then over the A, B, C and D generally I refer to the coefficient in balanced chemical equation. Let's proceed to tutorial questions. Question number 1, define the rate of reaction. So as we know, the rate of reaction is referred to change of concentration of reactant or product with the change in time. So part B, we are going to write the differential rate equation. When you want to write the differential rate equation, like mathematics, you will always see there is D in the equation. Okay. And then the rate over here basically is referred to rate of reaction. This one generally is referred to rate of reaction. So then you will notice that nitrogen and hydrogen are reactant. So that's why at here you will see there is negative sign. While for the ammonia is the product, so we'll have positive sign over here. And then we will refer to coefficient, which is 1 here, over 3 and over 2. Okay, again, they are referring to the coefficient in the balance equation. So for the second differential rate equation, Generally, I think I make mistake. This is not hydrogen. This one supposed to refer to NO2 because it is over 4, means that we refer to this. While for this one is over 1, so actually they are referred to O2, not ammonia. So for question number 3, all the coefficient here basically is referred to 1. So that's why you will not see any number over here. Now let's proceed to the calculation questions. Consider the reaction. 2 mole of Hi will produce 1 mole of hydrogen and iodine. Determine the rate of disappearance of Hi when the rate of iodine formation is 1.8 exponent negative 6 molar per second. So when we want to check this, rate of disappearance and also rate of formation and rate of reaction, what are their difference? So when we want to do this question, first step, we need to have a balanced chemical equation. Second, we need to write the differentiate rate equation. So rate of reaction equal to d negative dHi over 2 dt, and then equal to positive d concentration hydrogen over dt, and also equal to plus d iodine over dt. Okay, in this case, we are going to determine the rate of disappearance for Hi, and then you are given rate of formation for iodine. So means that here we have in the differentiate rate equation, we have 3. We have Hi, H2, and also I2. But in this question, we only need to focus on Hi and I2 only. Okay, Hi and also I2. So that's why the third step, I will just take the 2, which is referring to the Hi, negative dHi, concentration Hi over 2 dt will equal to positive d, here is iodine, I2 over dt. Okay, so based on this equation here, if there is a coefficient in the expression, it is referred to rate of reaction. So now they want us to determine the rate of disappearance. Basically, we can say that rate of disappearance is without coefficient. Where means you need to find out what is the value for this part. Okay, so means that we have to change the number 2 over here. We need to move to another side over here. Okay, so when we rewrite again, then here will be negative dHi over dt equal to, the operation over here is division. So when I move to another side, it will become multiply. So it will be 2 times the plus di2 over dt. So the iodine given in the question here is 1.8 exponent negative 6. So we are going to use 2 times 1.8 exponent negative 6. Then end up we will get 3.6 exponent negative 6 molar per second. Now let's proceed to tutorial question number 2. Propane burn in oxygen to give carbon dioxide and also water. If the concentration of propane decrease at the rate 0.25 molar per second, what is the rate at which the concentration of oxygen is decreasing? And then determine the rate of increase for all the products. So as usual, like just now what we discussed, first we need to write the chemical equation. And you have to make sure this equation is balanced. Second, we will going to write the differentiate rate equation. Do remember that the rate here is referred to rate of reaction. And then you will put the negative sign for the reactant, which basically are the C3H8, the propane, and also the oxygen are the reactants. And then the carbon dioxide and water are the product. So we're going to put positive sign. Next, why here is over 5, over 3, and over 4? Because this is like 1/3, 1/4, and 1/5 of the rate of disappearance or formation towards the rate of reaction. So where you can get this number 5, 3, and 4 basically is from the chemical equation. Okay. Why here there is no number? Basically the number here is 1. Because of anything over 1 is still the same. So if you didn't show, then it's okay. So and then again, the question here given us the rate of the concentration of propane decrease at the rate of 0.25 molar per second. When they gave us the concentration of propane decreasing, so we can say that these are referring to the rate of disappearance. So when it is referred to rate of disappearance, generally we no need to include the coefficient is okay. And also at this condition, the C3H8 only over 1, so the rate of reaction and also the rate of disappearance for propane is both of them are similar. Okay, we haven't started to answer the question yet. So like just now we mentioned, we need to determine the concentration, the rate of the concentration for the oxygen is decreasing. So when we want to do this, means that we're going to compare these two. Propane with the oxygen. So I'm going to write the negative dC3H8 over dt equal to negative d concentration O2 over 5 dt. Like just now we mentioned, if rate of disappearance always without the coefficient, okay, without the coefficient over here. So in this case means that we only need to find this part. So what's going to happen? This 5 will going to move to another side. Because of the operation here is division, so when move to another side, it will equal to multiplication. So means that d negative d oxygen over dt will equal to 5 multiplied with negative d C3H8 over dt. So which is 5, and then the rate of disappearance for the propane is 0.25. So we multiply with 0.25, which will equal to 1.25 molar per second. We no need to put the negative sign over here, is okay, because the negative sign already show here. So then we know that the concentration of reactant is getting less and less. Okay, we continue another part of the question. Next part of the question, we need to determine the rate of increase in concentration for all products. Okay, so means that again now we are going to compare propane with the carbon dioxide. So as usual, we just write down these two. Okay, since we are going to determine the rate of formation for the carbon dioxide, then we're going to write down positive d CO2 over 3 dt equal to negative d concentration C3H8 over dt. Like again, for the concentration rate of formation, similar with disappearance, is without coefficient. When without the coefficient means that we're going to move this coefficient to another side, which is multiply. Then positive d CO2 over dt will equal to 3 multiplied with the negative dC3H8 over dt. So in this case is 3 times 0.25, which is equal to 0.75 molar per second. So we repeat another one for the H2O. So positive dH2O over dt equal to negative dC3H8 over dt. So again, the 4 need to move to another side. So in generally, we already know it is 4 multiplied with 0.25, which will equal to 1.00 molar per second. So these are the answer for question number 2. One more question before you answer the exercise. So this question also from tutorial, which is in the objective part. So from the for the reaction, 4 mole of ammonia react with 3 mole of oxygen, produce 2 mole of nitrogen and 6 mole of H2O. The rate of formation for the ammonia, the rate of formation of nitrogen was found 0.018, and then you need to find out the rate of decrease ammonia. So as we already know, generally we need to have the general equation, chemical equation. Second, we need to write the differential rate equation. So in this case, because we no need to write the full, because this is objective question, and then we just like rate of reaction. Basically, we just need to involve 2, which is the nitrogen and also ammonia. So this is the nitrogen and these are the ammonia. So it's negative dNH3 over 4 dt equal to positive d nitrogen over 2 dt. Okay, can you follow so far? Okay, again, so now you are given the rate of formation for the nitrogen. So again and again, rate of formation and also rate of disappearance is without coefficient. So you need to determine the rate of disappearance for the ammonia. So this is what we want. So you are going to move to another side. So when you move to another side means that negative D concentration NH3 over dt is equal to 4 times 1 over 2 and then multiply with positive concentration and 2 over dt. So again, just now we say that rate of formation is without the coefficient. So means that is 4 times 1 over 2 multiplied with 0.018. So we can simplify this one, 1 and 2. So means that it's 2 times 0.018, which is equal to 0.036 molar per second. So the correct answer is C. Before we end this video, let's have a summary together. Basically, in this video, you need to know the definition for rate of reaction, and then you can know there are 2 types of rate of reaction. One is average rate of reaction, and then another one is instantaneous. Okay, generally the unit for the rate of reaction will be in molar per second. And then if you are given the graph, normally these are referred to the gradient of the graph. Second part, we're going to learn how to write the differential rate equation. Generally, before we can write the differential rate equation, we need to have a balanced chemical equation. Then based on the balanced chemical equation, you will be able to write the differential rate equation. When you write the differential rate equation, for the reactants, you need to give the negative sign, while for the products, you need to give the positive sign and also include the coefficient in balance equation, at where it is referred to rate of reaction. Then third part you need to understand is the rate of disappearance. When you can see the word disappear, so we know it is getting less, disappear. So means that the substance is referred to reactants. Well, if the question asks us about rate of formation, so what is formed? Product is formed. So that means the substance is referred as the product, at where it is without the coefficient. So by referring to the notes that we discussed previously and also the exercise that we discussed, then you will able to do the two exercises at the end of this video. Okay, these are the exercise that you need to answer. Question 1 and question 2 basically is how to determine the rate of disappearance and also rate of formation. We will discuss this during the tutorial time.